Hello everyone and welcome to Jigyasa Analytics webinar on reviving donors and subscribers with AI and synthetic data. Look at this chart in front of you. This is derived using 15 different brands, and for each of these brands we built models, and then this chart for each of these brands has hundreds of thousands of records. Now if you look carefully, you'll see that we have plotted the response rate for reactivation campaign by years since the individual lapsed. Could be a subscriber, could be a donor, or could be just a general customer. But what you notice is that as the time passes, the response rate goes down. But look carefully at the response rate after 5 years. It is still quite a good response rate. And this is an average across 15 different brands. In fact, over 10 years also, there is a fairly decent amount of response. So there is a lot of hidden response there at the tail of the old subscribers and donors. And organizations in general are missing out on this. And why is it that they are missing out on this? Let me talk to you a little bit more about that. There are a lot of organizations where experts in database marketing generate the actual list of subscribers or donors who have lapsed and who need to be part of the reactivation campaign. Now these lists are generated using certain rules, maybe data driven, segment driven, but almost always there is a rule on recency, and people who have expired or lapsed recently are given greater importance, and a lot of time there is a hard cutoff, maybe the last 2 years, last 3 years. It depends on the organization. And then there are organizations who actually develop models. Now most of the models that are developed are linear models like logistic regression models, and almost always there is a field there, time since expire or time since lapsed, and that is one of the top fields in the models. So recent expires, and rightly so, because they have a much higher response rate, are given greater importance by the model. As a consequence of all of this, there is not a lot of data available for solicitation of the older expires. Sometimes there is no data because there was a hard cutoff, or even when you are using a model, what happens is that you are probably selecting from the top of the models list, and in that list, uh, uh, since time since expire was an important field, the older lapse customers do not make the list. And then this is further confounded by the fact that you probably have very old demographic data for the people who expired 5 years, 7 years ago, and so you have to then think about that, hey, I have to now refresh this data and get some more recent data, which then adds to the budget, and we know how tight the budgets are, especially these days. Because of these reasons, it is a very daunting task for a lot of organizations to look into uh, going after these very old expires, even though the response rate you can get there is significantly higher than what you will get by going after prospects. So we have identified the fact that older lapsed subscribers or donors can be a very profitable and fruitful target for reactivation campaigns, but we have also seen the challenges associated with targeting them. So what is the solution? And we will talk now in some details about that. But first, let me give you an overview of the three things we can do. So the first thing is we can change our modeling methodology to address the recency issue. We talked of the fact that the models will give more recent expires a greater weightage, and so the selected list will have very few of the older ones. So we could introduce segmentation schema which will allow us to take care of this, and I'll talk in greater details about that. Or we could even use nonlinear tree-based machine learning algorithms which do a better job of this. The second issue is that AI generated synthetic data can be used for solicitation and response. And how will this help us? Look, we had said that there was very little data on solicitation for the older expires. So if we could generate this synthetic data, we will be able to address this issue, and we will talk about this also in greater detail. And then there is the issue of having very old demographic data and that being expensive. So we could use aggregated demographics, or we could use only internal transactions for these models. And this will address the high data costs. Let us now start going into details on the solutions we propose for soliciting to the older lapsed donors or subscribers. So we have the data and we fit a linear traditional model to it. But because the traditional model is a linear representation of the data, it kind of averages the main trends and likely misses out on some of the smaller sub-trends which might be available in the data. Now, so because of that, the traditional model will approximate the relationship with a single equation and will lose some of the non-dominant but highly responsive groups like long lapse donors. So we can solve this problem we said about trying to approximate the relationships with a single equation by segmenting the data. So say we segment the data by time lapsed and we create two segments, one with the more recent customers, say those who lapsed in the last 3 years, and then another segment for the older customers, those who lapsed after beyond 3 years. If we do that, then we have the ability to now fit two equations, one on the more recent lapse customers and the other on the older lapse customers. And doing that segmentation then allows us to capture some of the older customers and include them in our reactivation campaign. Another modeling approach we could take is that instead of segmenting the data, we could build a model which is a tree-based machine learning model. The tree-based machine learning model it does a much better job of capturing the nuances in the data, not just on the one field we have, which is the primary focus of our conversation today, that is the time since lapse, but also a lot of other fields. And in being able to capture those nuances, it will give the, for example, the older expires a greater chance to make it to the top of the list. Now, implementing these machine learning models is not very complicated. There are a lot of platforms and uh, uh, tools available for an organization looking to do it. But at the same time, it is a greater task than just implementing a single equation or one or two equations. So there is this additional complexity which has to be accounted for in moving from a simple equation to a more nuanced machine learning model. So we talked about modeling technique modifications, but what about the data? As we have mentioned earlier, not a lot of solicitation data is available for older expires or lapsed donors. Demographic data collected on them is also very dated, and the refresh is very expensive. So unless these data deficiencies are addressed, none of the modeling modifications we are talking about will be effective, because without the data, how do you build the model? So let me start the data discussion by introducing you to synthetic data. So what is synthetic data? It is artificially generated information that mimics real world data. It is derived using some mathematical algorithms, statistical processes, and more recently, AI. One big use of statistical generated or AI generated synthetic data is in data privacy. And it does not contain, general good synthetic data does not contain any direct or inferable private information. So we are focusing right now on long lapsed subscribers or donors, but as database marketers, we have seen a lot of developments in the consumer privacy space, and that is another reason for organizations to look into synthetic data for model development. So it has been around, synthetic data generation, for some time. There have been attempts to generate synthetic data, and in the early 2000s, for example, there was this mode technique which gave very promising results. But the real uh, leaps that have been made in this field have been due to the recent advances in artificial intelligence, particularly large language models and computer vision models. And that has led to significant improvement in the quality of the synthetic data that we can generate now. If you are interested in this details around this, we have presentations on this available on our YouTube channel. So synthetic data can be generated using the sparse solicitation and response data available to us. And then this can be then added back to the sample. So now in the sample we will not only have the sparse data uh, on the older lapsed subscribers or donors, but we will have additional records which were synthetically generated for them. And because of that, when we now try to build a model, the sample will have greater representation for them and will pick up their response. A question to ask at this stage, especially if you are not very familiar with the synthetic data processes, all this sounds well and good, but what is the quality of this artificially generated data? And so, uh, mm, I would again refer you for greater details to a YouTube presentation we have on our channel on this. But let me show you results from an experiment we did. So in this experiment, we took real data and we generated a model very similar to the model we are looking to build here for that exercise. And then we use that real data to generate some synthetic data and built a full synthetic data sample. And we built another model with that synthetic data. The line here you see in blue is the model performance for the real data, and the line you see in red is for the model performance with synthetic data. And as you can see, uh, that the model does model generated on synthetic data does fairly well, and that is why uh, it's very promising, and there are opportunities to fill our data gaps with that. So then what about the demographic data? So in our experiments with synthetic data, what we have observed is that as long as we have about 30 to 50 features, something in that range, the synthetic data does a very good job of duplicating the real data. But as the number of features expands, the quality starts deteriorating, and uh, demographic data fields have a very large number of fields, sometimes in the hundreds. So that is a concern. So one solution is feature reduction. uh, from our experience and using some other exploratory analysis, we could narrow down the demographic data fields and then generate it synthetically. So that's one solution. Uh, Another thing we can do is we can work with aggregated data. Aggregated data is aggregated at the zip4 level, or maybe at a carrier route level, and maybe sometimes at the zip code level. But we can work with aggregated demographics. Depending on the level of aggregation, there will be some predictability lost, but it still can be fairly predictive. And the third option is to work only with internal transactional data. And we have experimented with all of that, and there is some drop in performance in the 15 to 20% range if you work only with internal data, but it is still uh, a useful exercise to do, and it still will give you lifts. So a combination of these approaches will help you address the demographic data issue. And we are here talking about lapsed subscribers or donors, but we are all uh, facing the challenges of adapting to the new privacy regulations and uh, respecting the consumer privacy laws that have come about in the United States and Europe. And these approaches to aggregation and generating synthetic data have applications much beyond this specific exercise of sparse data for long lapse, but might be a necessity even when data is abundant. I hope you found this presentation useful. Thank you so much for taking the time to join us today, and we look forward to having you again in our future presentations.